Hi, this lesson is the first one in a new theme. So as you can tell from the background, um, we need to be working in our orange Theme 9 booklets. You were given these before we finished school. Okay, this topic is all about dating. It's a crucial part of geology. If we're going to understand the story of the Earth, we need to be able to put that story into order. I suppose it's like having the page numbers or the chapter numbers in a book. Um, if we're going to try and understand the book, we need to be able to understand where the different pieces fit into the story. Now, as geologists, we use quite a few different techniques to actually work out the age of rocks, whether that's the age of things relative to one another or the exact, what we call absolute age of an event that's happened in the geological past. Okay, as ever, when we start a new theme, we need to have a look at what's in a word. So what I'd like you to do now is turn to the back of your booklets, have a go at what's in a word. Can you come up with a definition for each of those terms? Press pause now and have a go at that. Okay, now we've had a go at what's in a word, let's start thinking about what we actually mean by age. We've got a whole series of different things here. This, you may have seen, is it's an exhibit in the British Museum. It's called a Rosetta Stone. This is how we can interpret hieroglyphics, because this has an inscription of hieroglyphics and also Greek that we can translate. So we can translate what the hieroglyphics mean. Is this an old thing? Well, the date on this is from 196 BC, 2,200 years ago. Long time? How about this? This is the stone circle at Stonehenge. Is this old? Well, there we're talking about 2,200 BC, 4,200 years old. Old? How about this? The Great Pyramids at Giza. Are they old? Yeah, about the same age as Stonehenge. These are fascinating things. These are what we call bristlecone pine trees. We find them high up in the Sierra Nevada mountains in California. These are the oldest living thing on Earth. These trees are actually alive, and they've been alive for very nearly 5,000 years. How about things going back further into the geological past? Woolly mammoths. When were they knocking around the Earth? Well, maybe only about 300,000 to 10,000 years ago. Is that old? How about the dinosaurs? We know they became extinct 66 million years ago. They evolved about 230 million years ago. So we're pushing further back now into geological time. If you think about the planet itself, if you remember from theme 0, this is about 4,550 million years old. So we've got this huge span of time to think about. Now, as geologists, we divide time, should I say, into this. This is a geological timescale. The key part of this are the geological periods. Starting from the Precambrian, going into the Cambrian period, named after Wales, then the Ordovician and Silurian periods, named after tribes that used to live here in Wales, the Devonian period, fairly obviously named after the county of Devon, The Carboniferous period, named because it contains carbon. That's where we find the coal and a lot of limestone. The Permian period, named after the Perm Mountains in Russia. The Triassic period, so named because it's split up into 3 bits. The Jurassic period, named after the Jura Mountains in France. The Cretaceous period, named after the chalk that we find within it. The Paleogene and the Neogene, the old and the new life. And finally, the Quaternary period. All of those periods, you'll notice I've given you the dates there, they're not evenly divided up. It's not that a period lasts, say, 50 million years. These periods are divided up based on what was happening in the Earth, particularly changes in life or the environments that we find on Earth. This is the basic way that we describe geological time. Okay, we'll get more and more familiar with this timescale as we work our way through the topic. We always, though, and you'll notice how I read this column, we always start from the bottom as geologists. The first thing, the oldest thing, will be at the bottom of the column. The youngest thing, the last thing to happen, will be at the top. It's one of the top 10 signs you're a geologist, is that if you're asked to write things down in time order, you start at the bottom of the page and work upwards. It's a habit we need to get used to. As well as these periods, we also have phases of mountain building, what we call orogenies. Precambrian saw lots of these, but the key ones, certainly the ones that affect Britain, are the Caledonian orogeny, which created mountains in Scotland and in North Wales and in Mid Wales. The Variscan orogeny at the end of the Carboniferous period, that, for example, made the mountains in the Brecon Beacons. And finally, the Alpine orogeny, as the name suggests, this is when the Alps were formed, only had a slight effect on Britain, and particularly in the southeast. But we'll look at that perhaps a bit more next time. Okay, next lesson, we need to start thinking about this idea of orogenies. These points through geological time where plates have come together in and around what's now Britain to make our mountains. We'll see you then.